Uh, this is a tutorial on how to debug and fix WebKit layout tests in the Chromium port of WebKit. Most of the information discussed in this topic is available on this website. It's linked off of the Chromium developer page, which is on dev.chromium.org. There's a lot of information on getting started with the test that this talk will not cover. It's covered on this webpage, and so rather than reiterating it, you can visit the webpage. So we're going to assume that you've already checked out the Chromium source tree, you've built it, and you have specifically the test shell project has been built. And this will cover how to actually run the test and fix a test. We have a test script in our source tree in WebKit tools layout test run WebKit test .sh that is used to run the tests. If you run it without any command line arguments, it'll run through all the tests using the release build of test shell. I've built a debug build, so I'm going to pass in the debug flag. And if you run this script, it'll run all the WebKit layout tests. There are over 10,000 of them. And letting it run takes a while. In most cases, you're only going to be debugging and fixing one at a time. So it's normally better to pick a subset to work on. We are going to work on, for the purposes of this example, the tests, the canvas tests. So you can pass an extra command line parameter to the script to run a subset of the tests. I only want to run the tests in the fast canvas directory, and so I pass that in the command line. And it'll run only those. As you can see, there are 68 tests. And it's running through them now. And basically it checks to see how many of them match the expected text output and how many of them match the expected pixel output. Normally when running through the tests, it'll give you a summary at the end of the run. In this case, it ran 68 tests, 60 of them passed, and some of them failed for various reasons. In this run, we also had an unexpected failure, as in this test failed, but we expected it to pass. Because of that, an extra window popped up so that we could debug this specific failure. And this is the test we're actually going to look at. When the test fails, you can look at a diff between the output that we expected the test to give versus what actually came out. As you can see, it was expected to output the word pass and some extra information, but instead it output the word fail, and it threw an exception. Syntax error DOM exception 12. So to debug this, normally I actually look at the source for the test that failed. The name of the test is canvas pattern behavior. The test itself pulls in from other places, so let's look at those. And we notice that it's trying to call context.createPattern somewhere. Here. It's trying to call context.createPattern, and it's passing in an image, and it's passing in null. And we're throwing an exception, a syntax error exception, which probably means we passed in something that it wasn't expecting. This is a difference because we're using V8, and upstream they're using JavaScript core. So normally if there's a bug in some of the JavaScript calls from WebKit, there's probably something wrong in the bindings layer between V8 and the Chromium port of WebKit. So we'll take a look at the bindings code. In V8, most of the custom bindings are in this file called V8 custom, which is in the WebKit port bindings V8 directory. Specifically, in the test that failed, it was failing on a call to create pattern. So we're going to look for create pattern. This is where the code for calling create pattern on a canvas element is run. To debug a little further, it's often helpful to look at Apple's code and their bindings between JavaScript core and WebKit. So I conveniently have a checkout of Apple WebKit on my machine, and I look at their bindings code for the JavaScript layer. It's laid out slightly differently, but it's still in the bindings JavaScript directory. Normally, you can just grep for whatever you're looking for and find the file that it happens to be in. We have one big file for all of our custom bindings. They have it split out by class. But we're looking for create pattern. And so that is in this method here. And we can flip back and forth between the V8 implementation and JavaScript core implementation to look for differences. We're calling into, on a canvas object, we want to create a pattern. The call to that in the V8 code happens right here. In the JavaScript core code, it happens here. And they're basically the same thing. Given the context to a canvas, it's calling the method create pattern, and it passes in an HTML image element, and it passes in the pattern that's trying to be created, which is basically passing through the second argument to the method. In the V8 code, you can see it passes in the HTML image element as expected, and then it creates a string out of the argument to pass into WebKit. In the JavaScript core code, it does the same thing. It passes in an HTML image element, and then it converts the argument also to a web core string to pass in. But it makes a different call to web core. It calls value to string with null check, and we're just converting it to a string. Additionally, if we recall back to what the tests look like, it's actually calling create pattern. There's a call to create pattern. It's calling it and passing in null as a second parameter. So it's a pretty good guess that the reason we're failing the test and throwing an exception is because we're passing in null, but our code is not expecting null. It's trying to convert null into a string and throwing a DOM exception because that's invalid. So instead of just converting to a string, we want to convert to a string with the null check. And it's actually called in two places in this file, in this function. So we want to change both of them. So we can save it, recompile. There we go. It recompiled a new version of the test shell with our fix, and now it's rerunning all the canvas tests. And this time, the test shell window did not pop up at the end telling us about the new test that failed, or the unexpected failure, because we're now passing the test that we expected to pass earlier. In general, that would be enough to fix this bug. You would go into test fixable, which is a list of tests I expected to fail, remove the test from that list, create a change list using GCL to include the change to code and the change to the test script, or the change to the code and the change to the test fixable list, and send that out for review.